do we exist? Not why. How is it that we, all matter, all planets, how is it that anything exists at all?
Because according to theory, according to physics, mathematics, no matter where you look, we shouldn't exist.
Because what we call energy is actually the result of a destructive interaction. Twin siblings that cannot coexist, that cannot come together. And when they do, they annihilate each other. By this logic, these opposing forces should have destroyed one another, and matter and everything else should never have existed. So what exactly are we talking about? We're talking about the extraordinary discovery of an obsessive, unconventional genius.
We're talking about Paul Dirac, a man so unusual that a book was written about him called The Strangest Man. A man whose single discovery turned the world of physics upside down. We're talking about matter's deadly twin. We're talking about antimatter.
To understand Dirac's discovery and what antimatter truly is, we need to go back in time, about 13.8 billion years, to the Big Bang. If we had a camera at that moment and could zoom in, all we would see is a ball of pure energy. No matter, no atoms, no anything. Not even light existed yet. An incredible concentration of energy that would give birth to the entire universe, and possibly other universes as well. Then, in a trillionth of a second, it goes from smaller than an atom to the size of an orange. The universe bursts into existence. About 1 minute later, it's already larger than our entire solar system. As it expands, it cools. And as it cools, countless subatomic particles begin to emerge. And this is where our story begins. Half of these newly born subatomic particles were the building blocks of everything we know, matter. The other half was its deadly twin, antimatter. This is where Paul Dirac enters the picture. Until 1928, we had absolutely no idea antimatter even existed. We knew about matter. We knew atoms, electrons, protons, neutrons, but that was it. And really, what could be more natural than accepting only what you can see and test? But then, Paul Dirac, while calculating how particles like electrons behave as they approach the speed of light, produced an equation that was incredibly simple, yet impossibly far-reaching. And this is where things get complicated. Imagine a question with two completely different answers. You calculate once, the answer is 10. Correct. You calculate again, the answer is 500. Also correct. That was Dirac's equation. Two different answers, two different outcomes, and both of them were right. The first solution described an electron, the one we already knew, a negatively charged electron. But the second solution, that was the strange one. It described something that didn't exist, something that shouldn't exist. What would you think in that situation? Most likely, you'd assume you made a mistake somewhere, that your formula must be wrong. And that's exactly what Dirac thought. It took him 3 full years working on this equation. Or rather, it took 3 years to gather the courage to tell people, look, I found something. Because no matter what he tried, the result kept pointing to one thing: antimatter. The first solution was an electron. The second, an anti-electron, nearly identical to the electron. Same mass, same spin,
but with one crucial difference. Its charge was reversed. The electron, as you know, carries a negative charge. This anti-electron, positive. The same particle, identical, but positively charged. That's why we call it a positron.
Wait, what? Hold on, we're not done yet.
Dirac's equation made things even more complicated. It wasn't just about the electron. It applied to all particles. If quarks exist, then antiquarks must exist too. And since quarks make up protons, then antiprotons must also exist. And it still doesn't stop there. If electrons and protons are the fundamental building blocks of atoms, if they're what make atoms possible, then yes, if atoms exist, then anti-atoms must exist too. And if atoms make up matter, and matter exists, then antimatter must exist too. This meant something extraordinary. If proven true, the number of known particles in the universe would instantly double. And just 4 years later, in 1932, Carl Anderson would capture this photograph. What you see here had every property of an electron, every single one, except it was positively charged. Positively charged. It was. Yes, antimatter had been photographed. Dirac's extraordinary theory was now proven beyond doubt. And this raises an enormous question, the biggest question. How does matter even exist? How is it that we are here at all? This isn't a philosophical question. This isn't some abstract existential debate. Because when matter and antimatter come together, do you know what happens? They annihilate each other. They completely erase each other from existence. Logically, if equal amounts of matter and antimatter were created after the Big Bang, which is what makes the most sense, then all matter should have annihilated with antimatter. There should be nothing in the universe, nothing but pure energy. So what happened? We don't know. Well, there are some theories. Here's one theory. Some scientists believe that matter and antimatter separated from the very beginning, that the antimatter is still out there, somewhere, existing in a universe or universes made entirely of anti-planets, anti-stars, and anti-galaxies. The other theory suggests that right at the beginning, after the Big Bang, there was a tiny, almost negligible imbalance between matter and antimatter. Matter had just a tiny edge over antimatter, and they even give us a ratio, 1 in a billion. For every billion antiprotons, there were 1,000,000,001 protons. And that leftover 1 in a billion of matter, it was enough to create everything we see today. The entire universe. And the magic behind this discovery, Dirac's formula, looks something like this. For most of us, it's nothing more than meaningless symbols, right? But I once heard a beautiful analogy at a conference. When you look at the sheet music for Beethoven's Ninth Symphony, most of us see nothing but meaningless symbols. But when someone who understands those symbols plays them on an instrument, hearing that melody is an incredible experience for everyone. You don't need to be Beethoven to appreciate the beauty. What we feel when we see the results, that matters just as much. And this is exactly what scientists, academics, and teachers need to do. Create a melody that everyone can hear, everyone can appreciate, so we can all experience the beauty of science. Anyway, this equation is just like that. When you apply it, what emerges is a beautiful melody, the symphony of antimatter. By the way, this equation is also considered the first unification of general relativity and quantum mechanics, just like quantum superposition. One question, two correct answers, both true at the same time.
And here, I think we can understand Dirac's astonishment all over again. You sit down with an equation and discover an entirely new universe. You uncover a whole new reality.
Now let's return to the evidence. Did antimatter simply vanish after the Big Bang? No. Matter and antimatter were both products of energy, and wherever there's energy, matter and antimatter can always be created.
And who enters the picture at this point? Of course, Albert Einstein, and the beauty of his famous equation, E equals mc squared. Remember what it tells us? Energy equals mass. Mass equals energy. We can convert energy into matter. In this process, both matter and antimatter emerge. But according to this equation, we can also convert matter back into energy. How? By combining matter with antimatter. When they annihilate each other, pure energy is released. And this is where things go absolutely insane. The speed of light squared enters the equation. What this means is, when you convert even a tiny amount of matter into energy, the result is an absolutely staggering amount of energy. As I mentioned in a previous video, if you combined the atoms of a single paperclip with their anti-atoms, the resulting energy would be equivalent to an atomic bomb. This enormous energy potential, while being scientific fact, has naturally become the subject of science fiction as well. In the novel Angels and Demons, remember? They were trying to save the Vatican from an antimatter bomb. In Star Trek, the Enterprise used antimatter power to travel faster than light. But here's the thing. This isn't just science fiction. It's reality. Just imagine if we could produce antimatter, store it, and use it. Can you even picture what would be possible? Let's talk numbers and some truly fascinating facts. Antimatter, as we've discussed, comes into existence alongside matter and instantly annihilates it. Because it exists for such incredibly brief moments, capturing and storing it is extraordinarily difficult. And here's something unexpected. Bananas produce antimatter. Yes, regular bananas. They contain a tiny amount of potassium-40, and as it decays, it releases a positron every 75 minutes. And so do we. The human body contains potassium-40 as well, which means we also produce antimatter. But as I mentioned, it annihilates the instant it interacts with matter, so we never even notice. Harnessing this enormous energy could be a civilization-changing achievement for all of humanity. That's why laboratories are racing around the world to capture antimatter. But so far, across facilities like Fermilab, CERN, and DESI in Germany, the total amount of antimatter ever produced is just 18 nanograms. That's 18 billionths of a gram. Barely enough energy to power the light bulbs in your house. And this work is incredibly expensive. Producing just 1 gram of antimatter would require an investment of trillions of dollars. And then there are neutrinos. Strange particles indeed. Their antimatter counterpart hasn't been discovered yet. In fact, theory suggests that neutrinos might be their own antiparticle, because they carry no charge. Some scientists believe these particles may be responsible for the matter-antimatter asymmetry that emerged after the Big Bang. But as you can see, we face an enormous challenge. We're dealing with an incredible, invisible force. We keep trying to capture it, and we keep failing, no matter what we do. But when we find a way, when we reach the point where we can produce, store, and actually use antimatter, can you even imagine what becomes possible? Interstellar travel. Infinite energy. limitless efficiency, boundless power.
But who controls this power and what they use it for? That's an entirely different mystery. Here, once again, we have to trust that humanity's deepest and most terrifying instincts have dulled enough for us to wield such power responsibly.
Because science itself is blameless, completely blameless. What matters is the intent of those who use it.
There's so much more to discuss on this topic, and we'll explore it all in future videos. Before we continue our journey toward black holes, we needed to clarify this subject, because we're heading toward territory where even quantum physics starts to break down. But before we go, one final question. When antimatter power plants are built one day, when we hold that terrifying energy potential in our hands, what scenario awaits us? Will humanity level up and become an interstellar civilization? Or will we destroy ourselves? I'd love to hear your thoughts. Let's talk in the comments. And as always, until we meet again, I'm glad you're here. Sending love.